Hello viewers, I am Pooja from PG Department of Computer Science and IT, Doaba College, Jalandhar. Today in this video, we will learn about the Simpson's 3 by 8 rule to solve a numerical integration. Simpson 3 by 8 rule will give you the integral value of a function. To understand this rule, consider an example. Suppose if you want to solve the numerical value of this integral minus 3 to 3 x raised to power 4 dx using 6 subintervals, and you want to use the method Simpson 3 by 8. First of all, to apply this process, compare this integral with the general integral a to b fx dx, and find the values of a and b. A is the lower interval of the integral. The lower interval of the given integral is minus 3. Therefore, the value of a is minus 3. The upper interval of the integral is 3. Therefore, the value of the b is 3. Also find the value of the function fx. The value of the function is x raised to power 4, as you can see on the screen. The function is x raised to power 4 and the number of subintervals are given to us, that is 6. If the number of subintervals in any case is not given to you, you can take the n as of your choice. After finding the values of a, b and n and of function, we will also calculate the value of h. The h is the width of the subinterval. To calculate the value of h, we will use the formula h equals to b minus a divided by n, where b is the upper interval of the integral and a is the lower interval of the integral, and n is the number of subintervals given to us. In the given example, we are given the value of b as 3 and the value of a as minus 3 and the number of subintervals as 6. From calculating these values, we find the value of h as 1. After calculating the value of h, that is the width of the subinterval, we will now construct a table of abscissa and ordinate values. The first value in the abscissa is minus 3, that is the value of a. For the second abscissa value, we will add the value of h into the value of a. By calculating this value, we get the second abscissa value as minus 2. For the next abscissa value, we will add 2h into the value of a, and by calculating this value, we find the value minus 1. Similarly, proceeding in this way, for the next term, we will add 3h into a. For the next abscissa value, we will add 4h into a, and for the next abscissa value we will add 5h into a, and continuing in this process and adding one successive term of h into a, we will ultimately comes with the highest interval, that is the value of b. Here we will stop calculating the values of abscissa And corresponding to these abscissas, we will calculate the ordinates by putting the values in the function. The first value in the abscissa part is -3, and putting the -3 into function, we get the first ordinate, that is 81. After putting the second abscissa value into the function again, we get the second ordinate value, that is 16. Continuing in this process and putting the values of abscissas into the function, we get all the ordinate values as 0, 1, 16 and 81. When we put the value of b in the function, we get the last ordinate value, that is 81. We will name all the ordinates as the first term in the ordinate column will be called y0. The second term in the ordinate table will be called y1. Third term will be called y2. Fourth term will be called y3. Fifth term will be called y4. Sixth term will be called y5. And the last term will be called y6. If you observe this naming, you will see that y0 is the first ordinate, y3 is multiple of 3, y6 is our last ordinate, and y1 and y2 will be known as the remaining ordinates. Similarly, y4 and y5 will also come under the category of remaining ordinates. For solving an integral is integral a to b fx dx is equals to 3 times h divided by 8 into the sum of first and last ordinate plus twice the sum of ordinates multiple of 3 plus 3 times the sum of remaining ordinates. Once again, see the table. The value of the first ordinate is 81. Value of the last ordinate is also 81. The value of the ordinate that is multiple of 3 is 0. And 16 and 1, y1 and y2 are the remaining ordinates. y4 and y5 are also the remaining ordinates. We will put all these values of the ordinates in the formula of Simpson 3 by 8 rule and will solve this formula equation. You can see we have put all the values at the subsequent places. The value of the first and last ordinate is 81 and again 81. The value of the ordinate that is multiple of 3 is 0. The value of the remaining ordinates are 16, 1, 1 and 16. By solving this expression, we will find the answer 99, which is the answer of the integral, numerical value of the integral. Solving the integral -3 to 3 x raised to power 4 dx using Simpson 3 by 8 rule. You can see the calculation. This is a very simple process. Thank you for watching the video.